Derivatives of trigonometric functions have interesting relationships with each other. Let's begin with sine, and in order to find the derivative of sine, we need to use the formal definition of derivative. After substitution, we realize that there's no way to factor, so we transform the sine of x plus h using the sine angle addition formulas. Then we can factor out the sines after rearranging them. We also know the special pattern as an input approach 0, sine of x over x equals 1, and cosine of x minus 1 over x equals 0. Knowing that, the derivative of sine equals the limit as h approaches 0 becomes 0 times sine of x plus cosine x times 1, we end up with the derivative of sine of x equaling to cosine of x. Simple, isn't it? Now we take a look at cosine. We begin with the same procedure, starting off with the formal definition and substitute, but we're going to transform the cosine x according to the cosine angle addition formula. Then we can factor out cosine x and end up with familiar cases mentioned earlier. Eventually, the derivative of cosine x will equal to the cosine x times 0 minus sine x times 1, giving us the derivative of cosine equal to negative sine. With those two derivatives in mind, we are able to determine the rest of the 6 trigonometric functions. Starting with tangent, a tangent function can be seen as sine of x over cosine of x, and knowing their derivatives, we can use quotient rule to evaluate the derivative. We use the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator all over denominator squared, and the top simplifies to be 1, due to the Pythagorean identity, sine squared plus cosine squared always equal to 1. The derivative of tangent becomes 1 over cosine squared, which is secant squared. The same concept applies for the rest, cosecant becomes 1 over sine, secant becomes 1 over cosine, and cotangent becomes cosine over sine. After repeating the operations, we will get the derivatives of the rest of the trigonometric functions. As we line them up, we can realize a pattern. The derivative of a cofunction of a function is the negative cofunction of the derivative of the functions. Now you've gained some knowledge. I'll see you next time, or never.